Welcome to our presentation of the Rapid Bond Flexamix, the first and only truly sustainable starch mixing system in North America. In an era of drought, with fresh water becoming an ever more precious commodity, many manufacturers are aiming to reduce their impact on the environment and practice sustainability. Corrugated plants are large consumers of water, with corrugator and flexo wash water being sources of wastewater in particular. Many corrugated plants will utilize wastewater treatment systems that are both expensive to operate and, despite their use, still result in a source of wastewater. By using up to 100% of the wastewater produced by a plant, the Flexamix provides the opportunity for corrugating plants to reconcile sustainability with their bottom line, while also potentially reaching zero discharge status. For years, corrugating plants have tried to use both treated and untreated wastewater in starch adhesive preparation. Unfortunately, results were mixed. Because of the inconsistency of the wastewater, the challenges always remain the same: variations in pH and a wide range of suspended and/or dissolved solids. Even using the wastewater in only the secondary portion of the starch cook process provided marginal results at best. With today's faster corrugators and the need to reduce the amount of starch applied to the board, consistency of the starch becomes paramount. As a result, few, if any, plants are using wastewater in the preparation of corrugating starch. They are, in fact, spending thousands of dollars a month to treat their wastewater, haul the solid particulate to a dump, and pay to put the treated water into the sewer. The Flexamix features an innovative patent-pending viscosity detection and control system, which, when used in conjunction with our hybrid mixing process, allows for the use of untreated wastewater, both starch and flexo, in virtually the entire batch process water. This allows the starch preparation system to become, in essence, a true zero-discharge process, capable of using a plant's entire wastewater discharge from the corrugator and flexos. The key to this is the viscosity detection and control system. This system is used during the entire starch batch process to continually monitor viscosity by automatically modifying the mixing procedure and formula to accommodate for variations in pH and solids. One of the problems with any viscometer used in the past, such as the falling ball mechanism or the vibrating plate, is that they were not designed for use with starch adhesive. With these moving parts, once the mechanism becomes contaminated with starch, the unit becomes difficult to clean, inaccurate, and in the end unusable as a method of measurement. The viscosity detection and control system has no moving parts and is automatically cleaned and calibrated with a small amount of water prior to the start of the batch. After the viscometer system has been cleaned and calibrated, additional water, fresh or waste, and starch is added to the tank for the first step in the batch process. After this, the remainder of the water, fresh or waste, and starch is added and mixed. Unlike viscometer systems in the past, this system actively measures and evaluates the starch during the batch process, displaying the viscosity on the screen in Steinhall seconds. Based on these values, specific program steps are used to add additional formulation ingredients. Once the desired viscosity is achieved, the final step is initiated and the batch is completed and sent to storage. Because of the precise and accurate measurement parameters of the viscosity detection and control system, the final starch adhesive produced is virtually guaranteed to be at the preset viscosity and gel point values. The starch produced using the Flexamix has many significant improvements over typical high-shear Steinhall starch. The improved rheology of the starch can result in cleaner machining on the corrugator and less starch used. Lower gel points can be achieved. The system is able to produce starch in a wide range of solids from 22 to 30%. Due to the very precise control of the swelling of the starch particles, particle size can be formulated for all paper grades, resulting in improved bonding to difficult board. And finally, because of the superior stability and reduced susceptibility to temperature viscosity changes, the starch can be stored at a lower temperature than what is needed with typical Steinhall starch, thereby reducing energy costs. It has been shown that the use of the Flexamix with the viscosity detection and control system, in conjunction with the hybrid mixing process, can significantly reduce the need for and use of a wastewater treatment system. This can save a company tens of thousands of dollars in chemicals and waste disposal alone. In addition, with the better bonding capabilities and reduced energy consumption, ROIs for the system have been shown to be as short as 12 months. Here is an example of an actual ROI calculated for a potential customer in the U.S. With the savings in chemicals and less dependency on expensive starch additives and rheology modifiers, the payback on a new mixing module is 10 months. In conclusion, this innovation of the Flexamix viscosity detection and control system, used in conjunction with our hybrid mixing process, allows corrugating plants to realize significant savings in both fresh water usage and a reduction in the cost of wastewater treatment chemicals. In addition, the starch produced with the Flexamix features improved properties over typical Steinhall starch, allowing for higher corrugator speeds and efficiencies, improved bonding with reduced dependence on additives and rheology modifiers. Plants also realize energy savings through lower cook, storage, and gel temperatures. These financial savings, paired with a corrugating facility being able to achieve zero discharge status, are not only good for the bottom line, but for our environment as well.